Okay, this is a short video to take a look at question 7 in the enthalpy quiz. And I'm not going to do the whole calculation, but hopefully just go through enough of the thought process to help get you to the end. So here we have a reaction equation. It's a thermochemical equation. It's the combustion of benzene, and it has the delta H associated with that. And the question is that the heat from the combustion of a certain amount of the benzene is transferred to a certain amount of water at a given temperature. And the question is, what's the final temperature of the water? Well, first of all, you have to visualize what's going on. So we have some sort of a container of water. And in this case, there's 7.866 liters of water. And it's at 15.2 degrees Celsius. And then we have some benzene, and it's a liquid, and then it burns. So we have this catch on fire, and when it burns, it heats up the water. So if we had a thermometer in the water, the temperature would increase. So the basic concept here is that the heat from the combustion goes into the water. And more specifically, the heat from the reaction will then be used to heat up the water. So the water has a mass, a specific heat, and a temperature change. And of course, the reaction will give off heat, and the water will absorb heat. So those will be opposite in sign. So the reaction heat will be opposite in sign to the heat for the water. And now just a couple specifics. We know the amount in milliliters of the benzene, and we know its density. So it shouldn't be too hard for you to take the milliliters of benzene, use the density to convert that into grams of benzene, and then use the molar mass of benzene to convert that into moles of benzene. And then you have to note what the reaction tells us is 2 moles of benzene, if it fully reacts, is going to produce 6,535 kilojoules. So the negative sign, of course, means heat given off. And then the amount, the 6,535 kilojoules, corresponds to 2 moles of benzene. So you can take the moles of benzene, whatever that turns out to be, and then note that there are 2 moles of benzene per every 6,535 kilojoules of energy given off, and that will then be some number of kilojoules of energy. It's going to be still pretty big, and in anticipation of the next part, you might just want to convert that into joules of energy. Either way, just pay attention to your units. And then whatever that number is, so here you're going to have some number of joules of energy. This is going to be the heat given off by the burning benzene. That heat's going to go into and be absorbed by the water, and we're going to assume that it's all absorbed. So that is going to then equal mc delta T for the H2O. So we can now say our number of joules, whatever that turned out to be, is equal to the mass of the water. Well, we know the liters, and water has a density of 1.00 grams per milliliter. So make sure you do the appropriate conversions to get grams of H2O from your liters. Specific heat of water, of course, is 4.184 joules per gram degree Celsius. And then it's actually probably easiest to just say, here's our delta T. And then we know the number of joules, we know the number of grams of water, we know the specific heat. So it should be fairly straightforward to solve for delta T. And then once you have delta T, whatever that turns out to be, the delta T will be the T final minus the T initial. And the T final is what you're trying to find. And the T initial, well, the water started at 15.2 degrees Celsius. So you will know the number of joules. That will allow you to get the delta T, so this will be a known value. The T initial is a known value, so then you can finally find T final. So again, quick recap. All the heat of the reaction when the benzene burns is assumed to go into heating up the water. The amount of heat produced by the burning benzene can be determined by converting the milliliters of benzene into grams and then into moles using the stoichiometry of the balanced thermochemical equation. 2 moles of benzene produces 6,535 kilojoules of energy. And that allows you to figure out the number of kilojoules and therefore the number of joules of energy. And then that amount of heat, that number of joules of energy, is going to equal the mass times the specific heat times the delta T of the water. Mass of the water and specific heat of the water are either known or easily determined. That allows you to solve for delta T. And then, of course, once you have delta T, you can find T final since you know T initial. Okay, so hope that helps. And ask other questions, and I will post similar partial explanations.